All right. So this is a video lecture for 5.1. I'll go ahead and upload these as soon as possible. So 5.1 talks about the perpendicular bisector theorem. I'm going to abbreviate that with the acronym PBT. So the first one, it says that if line PM is perpendicular to segment AB in this diagram, and MA is equal to MB, then we can state that PA is equal to PB. And so basically what this says is that if a line intersects a line segment and it forms a 90 degree, and the segment is bisected, or down the middle, then the two parts are equal in length. Now the next part would be that if we extend this into a triangle, we can say that PA is equal to PB. Now the converse of that is just that if PA is equal to PB, then line PM is perpendicular to segment AB, and MA is equal to MB. And so this is sort of like just an extension of some of the other theorems that we've seen in the text. The other one is the angle bisector theorem. So here it says that if ray QS bisects angle PQR, and then segment SP is perpendicular to ray QP, and segment SR is perpendicular to ray QR, then we can state that SP is equal to SR. And so that's the angle bisector theorem. Now, the next one is that if segment SP is perpendicular to ray QP, and here we can see, let me just finish that off, and segment SR is perpendicular to ray QR, and SP is equal to SR, then ray QS, and we're looking at this one here, bisects angle PQR. Okay, so those are the three theorems in this section that we're going to be looking at. Now, number 22, they're asking us to do the following. It says, determine whether A must be on the bisector of angle TXR. Let me put the X right there for you guys. And so when we look at this, one of the first things that we can see is that we cannot determine whether or not, based on this thing, we can see that angle TXA is not congruent to angle AXR. And so based on that information, since those two angles are different, we cannot state that A is on the bisector. And let me just write it here. And I think the key here is the fact that those two angles are not the same. They're not congruent. All right, looking at number 26. Here we can see that segment MB, this segment right here, is perpendicular to bisector JK. And here's JK right there. Now, the reason is that it intersects JK at the midpoint, right, and which is point B. Then, so that means that M is equal distance from J and K, and so therefore we can set this up to say 9x minus 18 is equal to 3x, and then what I'm going to do is I'm going to subtract 9x from both sides. So negative 18 is equal to negative 6. And then we divide both sides, and we get that x is equal to 3. And I believe they were just asking us to solve for x for this particular one. Yeah, what is the value of x? And so again, we know this because they tell us it's a right angle. They tell us that JB is congruent to BK. And so therefore, MJ and MK would be equal to each other. So MK is equal to MJ. All right. So now looking at number 52, we're going to go ahead and do this this proof here. And so what I'm going to do is I'm going to write my statements. Let me go ahead and put this in white. And the reasons for the statements. So the first one is the given, right? And they gave us that PA is equal to PB, and segment PM is perpendicular to segment AB at M, right? And so that's what they gave us. I'm going to write this as my number one. That's the given. Now, in this case, I believe that the first one that we can say is that segment PA is congruent to segment PB, right? And that is the definition of congruence. And of course, you can say, hold on, so let me write that again. You can see here, based on the diagram, that in fact PA is congruent to PB. So that's the definition of congruence. So the third step is that we can say, and we've done this several times in class, because this is a common side. PM is a common side for both triangles, if you will. And so this is the reflexive property of congruence. All right, so we've established that because it's a common side. And then the other thing that we can say is that PMA, based on the diagram, right? So angle PMA and angle PMB are right angles. And that's just the definition of a right angle, right? So that's that step there. And so looking at our next step, we can also say, because the angles are right angles, we can also say that the triangles themselves are right triangles. So we can say that in this case it would be A and P. And the next one would be B and P are right triangles. Right? So far we've sort of just gone off the diagram and off what they gave us at this point in time. So the sixth step that we can do is that we can say that triangle ANP is congruent to triangle BMP, and the reason is the hypotenuse leg theorem. And so if you go back and look at the hypotenuse leg theorem, let me go back to the section in the textbook here where it's at. I believe it's 4.6, page 194. And it says that if triangle PQR and triangle XYZ are right triangles, right, and then of course two of the legs are congruent and the hypotenuse is congruent, then the triangles are in fact congruent. So remember, in order to use the HL theorem, they have to have two right triangles. Triangles have to have congruent hypotenuse, which we have here, right? Which is, in this case, it would be PA and PB, and at least one pair of congruent legs. And so the congruent legs here would be, of course, the shared segment, which is segment PM that we have there, right? Let me get back to number 22 here. 52. And so right now we have that sixth step. Now the seventh step here that we have is that we can say that segment AM is congruent to segment BM, And that is the congruent parts of congruent triangles are congruent. So AM is congruent to BM, right? And so we can sort of lay that claim here, just doing that based on some of the information that we have before. And then, of course, since AM is congruent to BM, it follows that M is the midpoint of segment AB. Right? And then that's just a definition of midpoint. And then, of course, the last step that we have is that P is on the perpendicular bisector. And that's just the definition of a perpendicular bisector. And so this is a 9-step that we did pretty much. And based on the diagram, we simply just added the two congruent symbols there to show that AM is congruent to MB or BM. And so that wraps up number 52 and 5.1. Thank you.